Hello everyone, this is the next part in our series on software testing tutorials. In this video, we will discuss different levels of software testing and go over each of these testing levels in details one by one. When software is being developed, it is essential that it goes through a series of quality checks before going live. Some quality tests are done during the development phase and some are done once the development phase is complete. The idea is to make sure that once the software is developed, it satisfies all the business requirements and is free from bugs or issues. To achieve this, we need to test the software in a structured manner. Whether you're using the SDLC model or the Agile model for product development, it's important to perform different levels of software testing to ensure that the product is developed correctly and that a quality product is finally delivered. In its life cycle, software goes through 4 different levels of testing. First, unit testing. Second, integration testing. Third, system testing. And fourth, acceptance testing. Let's explore each of these testing levels in details one by one. Unit testing is the first level of software testing when we develop large-scale software. We divide it into different components, or if we consider modern-day architecture, we break our application into different microservices. Each of these microservices contains a set of classes and functions, which are the smallest units of software. In unit testing, we test these smallest units of application, such as the classes and functions, to ensure that they are working correctly. Suppose we have an e-commerce website and it has product management microservice responsible for managing product listings. Within this microservice, we have functions like adding a product, updating its details, and calculating discounts. Unit testing focuses on these individual functions or methods. For instance, let's say we have a function that calculates the price of the product after applying discount with a function named calculatePrice. In unit testing, we would write test cases to check if this function accurately calculates the discounted price for various scenarios: a 10% discount, a flat $5 off, or no discount at all. By doing this, we ensure that the logic inside that function is correct. Developers write unit test cases during the development phase. This serves 2 purposes. First, they can be sure that the code they are writing is working correctly. Second, it helps maintain the code in the long term. Suppose in the future, another developer makes changes to the same code. They want to be sure that they have not broken the existing functionality. That's where unit tests come in handy. Unit tests get executed when we build the code. If a unit test case fails, our code will not build successfully, indicating something is wrong in the specific code that the particular unit test case interacts with. This helps the developers to fix the code right away. In large code bases, where we usually have millions of lines of code, a small change can break the whole application. That's where unit test cases are very helpful, as they help finding issues at the development level and help maintain the code in long term. Once a component or microservice is unit tested successfully, it then moves to a next level of testing, which is integration testing. Integration testing is the second level of software testing, where we verify if different components or microservices work correctly when used together. Basically, in integration testing, we test if the components are interacting with each other properly or not. For example, consider an e-commerce site with different microservices in the backend, like user authentication, order management, inventory management, and payment processing, etc. In integration testing, we test how these microservices communicate with each other. For instance, if a user has already added an order to the cart, but the product gets sold out, will the inventory service notify the order management system that the product is no longer available, and will the order status change accordingly? In another scenario, suppose a user makes a payment for a product, but the payment service rejects it. In this case, the order should be marked as cancelled by the order management system. The inventory should remain the same for that product, and the user should receive a proper notification. There can be various scenarios like this, where these components interact with each other, and in integration testing, we need to test all these kinds of scenarios. Some of these tests will be automated and some will be manual. Integration testing is very helpful in large-scale applications, where there is a separate team for each microservice. If a microservice has been updated, developers can run automated integration tests before releasing it to the testing team to check if their service is interacting properly with other components of the application. Integration testing is often a joint effort between the developers and the testers. Developers might start by performing initial integration tests as they combine different modules or services to ensure that they work together. However, dedicated testers from the testing team may also be involved in integration testing, especially in larger projects. Now, there are 4 types of integration testing: Big Bang integration testing, top-down integration testing, bottom-up integration testing, and sandwich integration testing. We will discuss each of them in details in the upcoming videos on integration testing. Basically, integration testing is all about checking the interactions of different parts of this system. With this, let's now move on to the next level of software testing. System testing is the third level in software testing. System testing is done after integration testing. In system testing, we test the entire system as the complete product. For example, if your product is an e-commerce website, it might have 10 microservices behind the scene. However, in system testing, we treat the e-commerce website as a single entity and test it end to end. Basically, in system testing, we focus on testing the complete functionality of the application rather than just selected parts. System testing includes all microservices, the user interface, the database, and the external APIs as well. System testing is typically performed by QA testers or dedicated testers. In system testing, testers perform tests that mimic real user behavior. For example, if a product is an e-commerce website, test cases will include the entire shopping process, browsing products, adding items to the cart, applying a discount code, checking out, and receiving an order confirmation, etc., etc. The goal is to ensure that the website functions as expected in the realistic environment. System testing also involves non-functional testing aspects, such as performance and security testing. The testing team will test how the website handles a large number of users during a sale event or ensures that the user data is encrypted and secure. This level of testing helps in catching issues that might not be visible when looking at individual components. System testing ensures that the complete application works properly and meets all the specified requirements. Once the testing team completes system testing and gives their approval, the product moves to the last level of software testing, that is acceptance testing. This stage involves testing by actual users, stakeholders, or dedicated quality assurance team to ensure that the product meets the business requirements and is ready for release. In acceptance testing, we first install the product in a special environment which is called the UAT environment or user acceptance testing environment, and add the actual user data to it. Only customers and QA team have the access to this environment because it mimics the production environment in terms of data and setup. Certain actual users from the customer side, stakeholders, and a dedicated quality assurance team then test the application in the UAT environment. They perform two types of acceptance testing: user acceptance testing and business acceptance testing. User acceptance testing involves a set of end users testing software to ensure it meets their needs and expectations. Business acceptance testing, on the other hand, focuses on verifying that the software aligns with the business strategic goals and is usually done by the stakeholder team. The focus of acceptance testing is on the real world scenarios and ensuring that the software provides a positive user experience. For example, if your product is an e-commerce website, users will test the site by searching for products, testing delivery options, and going through checkout process. If the site offers features like user reviews or wish lists, those would be tested too. Acceptance testing is like the final stamp of approval. If the software passes this stage, it means it's ready for public use. It's essential because it provides confidence that the product not only works technically but also satisfies users' requirements and business objectives. So these were the 4 levels of software testing. We will discuss each of them in even more details in the upcoming videos. So stay tuned and please do not forget to subscribe the channel.